Hello everyone, my name is Yash Bhatt, and this is my final project for Stat 512 on concrete compressive strength. So this presentation is going to be divided up into 5 main parts: introduction, data characteristics, preliminary analysis, model building, diagnosis and validation, and finally the model report and applications. So let's see the introduction of our project. Concrete has been used for decades as an important mixture of materials used in construction. It is the most commonly used man-made material on Earth. The compressive strength of concrete tests its ability to withstand loads that will decrease the concrete size. It is an extremely important factor to measure the usefulness of the concrete in question, and there has been prior research carried out that has used machine learning methods such as neural networks that have predicted concrete compressive strength. So the two research questions that I'm basing my project on are to develop linear regression model that predicts the concrete compressive strength, and to discuss the roles of said predictor variables onto the model in question. Now, let us go over the second part of the project, which is the dataset's characteristics. So we have a sample size of the dataset as n equals 500. We've got 8 predictor variables, which are namely cement, blast furnace slag, fly ash, water, superplasticizer, coarse aggregate, fine aggregate, and age. These are all shaded in blue. We have one response variable, which is in yellow or gold, which is the concrete compressive strength. It is extremely important to note, however, that all the variables are continuous, not categorical. Moving on to part 3 of our presentation, the preliminary analysis, which is going to help us learn a little bit more about the dataset at hand. The following are different histograms for each of the predictor variables mentioned in part 2. The importance of this is to figure out what the overall distributions look like. We can see that the histograms with arrows pointed at them are very close to what one would see from a normal distribution. In other words, they resemble data that would be normally distributed. The other 4 predictor variables are not normally distributed. This portrays that there will be some normality within our data. However, at the same time, a certain amount of remedying is going to be required. This particular slide shows all the scatter plots of the predictor variables. It isn't very easy to identify any patterns of these scatter plots, simply because of the large number of variables required. Some look related, while others simply don't. Some are just too difficult to tell. As a result, we're going to have to resort to the correlation matrix. So this matrix is an easy way to identify collinearity between the 8 different variables by looking at their respective R values. Looking at this matrix, it is easy to identify that water and superplasticizer have the largest amount of collinearity between them. That's because they have the largest value, which is 0.6198759. On the other hand, there is a smaller amount of collinearity between the other 2 circled numbers, 0.36058868 and 0.3990231, for water and fine aggregate, as well as superplasticizer and fly ash, respectively. So this slide takes a look at our variables' residual plots. The plots with arrows pointed at them all show evidence of non-constant variances and patterns. These are namely furnace slag, fly ash, superplasticizer, age, and water. Coarse aggregate and fine aggregate appear to have almost no relation within their respective plots. Now let's take a look at our data set's influential points. I have calculated the hat leverage value to be 0.036, Cook's distance value to be 0.928, and the studentized deleted residuals value to be 3.922. I've calculated these three values in order to compare with the influence plot to see whether any of the data points can be called as influential data points. The points 199, 257, 391, and 500 that correspond to the respective hat values are outliers, and no influence points can be shown from the Cook's distance values, and no outliers can be showed from our stud rest values. As a result, the points on this dataset are very likely to not require remedial action. This means that it's going to be much easier for us to make our predictions. Let's take a look at what the preliminary analysis was able to tell us. Firstly, multicollinearity exists, however at minor proportions. My closing remarks for that would be that not much remedial action is required. Next, there are some problems associated with the data's normality and constant variances. Further normality, as can be seen from the first histograms of this presentation, furnace slag, age, superplasticizer, and fly ash have the largest issues. Let's move on to part 4, which is model building, diagnosis, and validation. We're going to start this off with the best subset analysis and the added variable plots. Let us pick model 8. So this is because that this model has all 9 of our required predictor variables, as well as due to the following reasons. The R-square and the R-square adjusted values are both non-decreasing. This portrays a full model. The CP and the AICP values in model 8 are also the smallest. The SBCP is the smallest for model 5. And the PRESP is smallest in model 8. Therefore, I can say with certainty that despite the SBCP being the smallest for model 5, all the other data values portray that model 8 is going to be the model that we use. Next, the added variable plots show that all of the predictors have a linear impact on the response variable. This exactly confirms what we found out through the best subset analysis. Now let's look at our first order full model. Immediately looking at the f-test statistic, we can make a conclusion that at a significance level of alpha equals 0.05, at least some of the variables have a large linear impact on the response variable. We also need to take notice that the adjusted R-square value needs to be corrected to be higher. It is currently at 0.6029. Now, let us compare the type 1 and the type 2 ANOVA models. The order in which the variables are entered matters. This can be seen when put the first ANOVA and second ANOVA side by side. This suggests that the variables have a chance of being interdependent within each other. Now let's take a look at the residual plots for the model's diagnostics. Immediately after looking at these residual plots, we can tell that there are going to be some issues. Several plots have issues with linearity. Age and superplasticizer plots are extremely nonlinear, while slag, fly ash, fine aggregate, and the fitted values are somewhat nonlinear. Our focus is going to be on the age and the superplasticizer, as those two are the most extremely nonlinear, we're going to take a look at those two predictor variables to remedy in order to make for more accurate predictions. Looking at the slide, we can see that age is a huge curve, superplasticizer quite a bit, while the rest follow more linear movements. So to check for normality, I used the Shapiro-Wilk test. The null hypothesis for this test is that our data follows a normal distribution, while the alternative is that it violates said normal distribution. Our conclusion based on this test is that the null hypothesis cannot be rejected. Therefore, it passes the normality test. So I decided to transform the age predictor in order to meet the linearity assumption. An individual transformation of said age predictor variable is the model that I decided to transform. I think that it was necessary to do this to meet the linearity assumption. The final model that I picked is the last predictor transformation, which is the individual transformation that I'm currently talking about. Looking at the residual plots for this model, we can tell that the assumption of linearity is met overall for this model for pretty much relatively all the variables. In the final slide, we can see that the R adjusted value has indeed increased from what it was before. It is now 0.8123 as compared to a 0.6 value. Thank you, and if there are any questions or comments, please email me at the email address provided.